Good morning. We are jumping ahead a little bit here in our book. We have 4 different ways to solve quadratic equations. The first one is through graphing. It is a little bit difficult to graph quadratic equations, and so I'm a little worried about doing it remotely. So when we're done solving quadratic equations the 3 other ways over the next 3 classes, I will show you guys how to graph quadratics and just so you have an idea for next year. Okay, so we're going to move on to 8.6, which is the second way to solve quadratic equations. So the second way to solve quadratic equations is by factoring. Okay, so in order for you to solve through factoring, you have to have a trinomial or an expression in general that can be factored. Okay, so that's what we're going to focus on today. So if we take a look here, the first thing you need to learn is something called the zero product property. We are going to use that property to solve quadratic equations. And basically what that is saying, you use the words zero product property. If you have 2 numbers and you multiply them together and the product is 0, you can find what those values are. We know that 3 times 0 equals 0, or 0 times any number is 0, right? So algebraically, that tells us if we have A times B equaling 0, then A has to equal 0, or B has to equal 0, or in some cases, both have to equal 0. So we're going to use this knowledge to be able to solve quadratics. We're going to start off by just practicing the zero product property. So this is a factored equation already. So this is a quadratic that has already been factored, and there's a little trick to solving this, okay? What you do is, the long way to do this is you would set both factors. So the x minus 7 is one factor, and x plus 2 is another factor. You'd set both those factors equal to 0, and then solve for x, okay? And this is just a normal single step where you add 7 to both sides or subtract 2 on both sides, and voila, you got your answer. So you have x equals 7 or x equals negative 2. Now, there's a trick to this. The trick is, okay, and it's like a 2-step trick. If you have a 1 in front of these x's, just take the opposite of the number. So the opposite of negative 7 is 7. There you go. And the opposite of 2 is negative 2. Wow, there you go. So technically you don't even need to set these up, but that's the how behind it. Okay, let's take a look at another one. Oh, that's just checking your work. Okay, we have x minus 2 times x equals 0. So I know that this has to equal 0, or this has to equal 0. So the x minus 2, if I set that equal to 0, guess what? My answer is x equals 2. I'm taking the opposite of this. If you don't believe me, we can set it up by using the zero product property. They flipped these. Okay, they set this x equal to 0. Well, guess what? It equals 0. And then in this case, they set x minus 2 equal to 0. When you solve for x, you get 2. So our solutions are 0 and 2. Okay, so that's how you apply the zero product property. Let's do this one really quick. Without even setting it up algebraically, I have x plus 4 times x minus 3, and that's equal to 0. Take the opposite of this, which is negative 4. Take the opposite of this, which is positive 3. Our answers are x equals negative 4 or x equals 3. Okay, this is checking. Okay, so now we're going to get into the meat and potatoes of this. If you have a quadratic equation that's written like this, where all your, everything's on the left side and it's set equal to 0, what we can do is factor the left side or the right side, whichever side is not the 0, and we can use the zero product property. Okay, so let's take a look at our first example. And here's why FOIL was so important in chapter 6, and then factoring was so important in chapter 7, because you're actually applying it to, equations as we go forward. So if I needed to factor this, first of all, everything's set equal to 0, so we don't have to worry about that. When I go to factor this, and again, I'm assuming you know how to do this, so we go straight into the factoring. We get x minus 4 times x minus 2. That's equal to 0. So we just take the opposite. X has to equal 4 and x has to equal 2. Okay. If you want to use the zero product property to set them up, you're just taking this, x minus 4, setting it equal to 0, and then this, x minus 2, and setting it equal to 0. Okay, so our answer to this quadratic equation is 4 and 2. Those are our solutions. You can always check by plugging and chugging, okay, just to see if it works out, but I'm just going to skip over that. Okay, now this one's a little different because we have x squared plus 4x equals 21. What do we notice over here? This is not a 0. So before we can move on, we have to move this over to the left side. So to do that, we're going to subtract 21 on both sides. And now we have a quadratic that's set equal to 0. That's exactly what we want. Okay, so next step is we're going to factor our left side, and we get x plus 7 times x minus 3. We're going to set that equal to 0. And again, you can take the opposite of this 7 and make it negative 7, and then opposite of negative 3 and make it positive 3. You can set them equal, do the zero product property too, but you can use that little shortcut of the opposites. So our solutions are negative 7 and 3. Again, you can check it by plugging and chugging. Okay, here we go. Here's another one. X squared minus 12x plus 36 equals 0. Okay, what I noticed off the bat, right off the bat, without doing this factoring, I noticed that this was a perfect square trinomial. So you could even write this as x minus 6 squared. Okay, they're the same thing. So you really don't even need to set them up twice, do you? Nope. Our answer is x equals 6. Okay, you don't need to write it twice. I'm not sure why they do that, but just write it once. Okay? Ooh, this one's good. Negative 2x squared equals 20x plus 50. The first thing I notice, there's two things I notice. We don't have a side that's equal to 0, so we have to fix that. And then there's also a negative in front of this 2x squared. Okay, so those are both things that we need to take care of. To get rid of this negative, I would actually add 2x squared to both sides. That would just make it easier the way we're used to seeing it, with positive leading coefficient and everything all on one side. Okay, so we have that equal to 0. Now this is a complex factoring problem because this has a GCF, which is 2. Okay, and we can factor out that 2. When we factor out the 2, we're dividing each of these terms by 2. So our remaining trinomial is x squared plus 10x plus 25. Okay, this is also a perfect square trinomial. I just know that because I've been doing this forever. But they decided to put it out as FOIL instead of a perfect square. So whichever way you want to do it is fine. And then we've got the zero product property. So we don't have to worry about this 2. There's no variable with it, so you don't really have to do anything with it. Okay, but we know that x plus 5 has to equal 0. Okay, and when we take the opposite of that, it's negative 5. So our answer, there's one answer to this, which is x equals negative 5. All right. So I'm going to kind of skip on to one that's a little bit harder. Let's see here. So we have 30x equals negative 9x squared minus 25. So again, this is something that's a little weird. We want to put it in standard form so it's easy for us to factor it eventually. When we move this 30x over to the other side, they kind of skip a step, but they subtracted 30x on both sides. We get negative 9x squared minus 30x minus 25. As I stated in one of the previous examples, we don't want a negative leading coefficient. So we're going to factor out that negative, or negative 1, same thing, and then turn all these guys positive. Okay, now we can factor this trinomial. Again, this is a perfect square trinomial. They don't show it that way, but it is. So when you factor this, you get 3x plus 5 times 3x plus 5, or you can even say 3x plus 5 squared. Okay, now you can't do the little trick here where I said take the opposite of this, because there's a number bigger than 1 in front of the x. But there's another little trick. So you can take this number, make it opposite, so negative 5, and then put it over 3. Okay, and it'll make sense when I show you this. But 3x plus 5 equals 0, solve, and they don't show you the steps. But if you subtract 5 on both sides, you're left with 3x equals negative 5. You're going to divide both sides by 3, and you get this. So let me reiterate that trick. The trick is take the opposite of this divided by the number in front of the coefficient. So negative 5 divided by 3. All right, let's try this one. 3x squared minus 4x plus 1 equals 0. Okay, we're going to factor this, and we have 3x minus 1 times x minus 1. And guess what? We're going to do our little trick. We're not even going to set them equal to 0, but we can take the opposite of this, which is positive 1, divided by 3. So one of our answers is going to be 1/3. The other answer is going to be 1. We have opposite of this. There's a 1 in front of here. Okay, so if you use the zero product property and you solve, you'll get those answers. X equals 1/3 or x equals 1. Okay, now we have a word problem to take a look at, and there's a lot of words. So don't, when you see a word problem, don't freak out. Try and extrapolate the important stuff. So the word problem says, the height in feet of a diver above the water can be modeled by h of t, that's just function notation, h of t equals negative 16t squared plus 8t plus 8, where t is the time in seconds after the diver jumps off the platform. The h stands for height. The t stands for time. We want to find the time it takes for the diver to reach the water. Okay, so what we're going to do, the important thing here is this equation. That's about it. Okay, so what we're going to do is set up our equation, and you have to think about it. The diver is going to reach the water when you're at the height of 0. Okay, that's kind of like where the ground is, where the water is. Okay, that's 0. So we're going to set this equal to 0. We're going to factor, and the first thing we can do is factor out the GCF of negative 8. And then we're left with 2t squared minus t minus 1. We're going to factor the trinomial, and we end up with negative 8 times 2t plus 1 times t minus 1. Then we're going to use the zero product property. So I kind of clicked through that fast, but we're going to take each of these and set them equal to 0 and solve for t. So when we solve for t, we get t equals negative 1/2. Well, that's a problem. We can't have negative time. And then we get t equals 1. So the diver is going to reach the water in 1 second. Okay, it's as simple as that. Don't make the word problem out harder than it has to be. Okay, so that's solving quadratics using factoring in a nutshell. Your homework is 565, number 7 to 19 odd. I'm going easy on you guys. Make sure you put that into the Google form. Just your answers, but hang on to your work in case you have any questions. All right, have a great day.